In this project, we're going to create an app that uses machine learning to play the game of PICaboo. You might be familiar with this game. It's basically a game that parents play with their very young children. Children at a very young age do not quite know what to make sense, how to make sense of the visual information that they see. So what the parent does is they cover their face, and the baby is suddenly surprised to see that the parent is gone, and the baby might feel sad for a second. But then the parent suddenly opens their face, and the baby is delighted to see the parent appear out of nowhere. So it's a fun game people play with their children. What we're going to do is we're going to have some machine learning environments where we could do some image classification. So without further ado, let us go to this page called classifier.appinventor.mit.edu. And on this page, we have, first of all, what is called a training page. And what we're going to do basically is we're going to capture some images, and we're going to associate these images with a specific class. For example, I'm going to go here where the plus sign is, and I'm going to create a label. I'm going to call the first label me. These are all these are going to be all the images of me where my face is showing and it's not covered. And let me create another class. I'm going to call this one not me, and I'm going to actually leave no space between not and me because it will actually help in our coding in a few minutes. So these are the two classes. And what I'm going to do is let's go to the me class first. I'm going to capture a number of pictures of me showing my face from each side, from different distances, maybe smiling, not smiling, etc. So let me do that. So let me take a picture of me now from a different angle, now from a different angle, now from distance, closer up. So these are all the different pictures of me where the baby is going to recognize that this is me, my face, seeing my face. Now, we recommend that you try something in the order of between 25 and 50 images. By the way, you can scroll up and down, and if there's any image that you don't like, for example, this one feels too far, I'm just going to click on the cross symbol right on the upper right corner, and that will eliminate that picture. You could take another one instead of that, etc. Now let's go to the not me class, and there I'm going to cover my face and take a bunch of pictures from, again, various angles, various distances, various styles of covering my face. So let me do that. So you may want to crack your fingers a little bit while you're doing this so you can see what you're doing. So I'm going to capture a picture covering my face. I'm going to do this closer, farther, from each side of the room, etc. So let me do a few of these. And then I'm going to switch my hands, and I'm going to do it again, but this time with the other hand. And again, I'm going to capture some pictures. Let's do 30 for each. Again, if there's any one of these that you do not like, so let's say this one I don't like, you can click on the upper right corner, and you can capture another new one instead of that. Okay? So you could play around with this several times, but what we have done is we are basically associating some images of me showing my face as the me class, and some images of me covering my face as the not me class. So these are basically associations we're giving to images and words. Now, when you're satisfied with your images, there is a train button here. You click on that, and the machine is going to do some training based on these images, and it's going to create a model. And the default values here are more than enough, so you don't have to change anything while it's training. But the loss value being small is good. That means it's learning quite well. So we're going to wait for a few seconds until these are done. And when it's done, when the model has been created, you come to what is called the testing page. And in the testing page, you can actually capture some new images that the computer has not seen before and see if it's going to be classified correctly. So let's capture a picture of me showing my full face and smiling. And observe what happened is this button became green, and it is reporting when you hover over it, it will say, oh, 99.93% confidence. The machine knows that this is the me class, me showing my face. So let's do one that is a little bit further out. Let's see what's going to happen. It's still recognized. Now let me cover my face. You notice that it immediately, the green light showed up on this button that says not me, and the confidence level for not me is very high. Okay? Now, you can try different poses, so let me try that. It still knows that it's not me. Let me try that. Let me try my hands a little bit, my fingers spread. Still recognizes that. How about if I just put my finger here? Let's see what's going to happen. It can see majority of my facial area, so it recognized this as me. So you could test to your heart's desire as many times as you want, and when you are getting correct classifications, and the test results are here, it's basically showing you all the instances where the new images you gave the machine are recognized as me and not me. When you're satisfied with this, you basically are ready to export your model. Okay? So there are two buttons here. One of them is the export model. And actually, let's just do that. When I click on that, it basically downloads a model.mdl. I had a number of them before, so that's why it's called model8.mdl, but it should just be called model.mdl. So this is what we're going to be importing into App Inventor. Now, it's possible that after you play with App Inventor for a while, you want to actually go back to your training data and add some more samples or change some things, etc. For you to be able to do that, you have to export training data as a zip file so that you can later upload that again and access your training data. Okay, so when you click on that, it's going to create a data.zip file. Now, if at this point you were for some reason unsatisfied with something, let's say some of my images were incorrectly identified as me or not me, you could go to the training page by going to the upper left corner here. When you press the train button, you will arrive at the training page one more time. And let's say I was not satisfied with me. I want to add 20 more samples, so I'll just add more samples of me, smiling, going back, etc. I do that for a total of 50 times. Now let's do the same for not me. I'm gonna cover my face and have some on this side, some on that side, some like this, some like that, etc. Observe actually here I have much more than the other one. I have 66 examples as opposed to 50 examples. So I just want to make sure they're the same for both. So what I can start doing is I can start erasing some of these. So I will have exactly 50 each. It's not a big deal, but I personally like to keep them the same number of samples. Okay? So the more examples you have, the better the training is going to be. So again, I press the training button. It's going to take a few minutes. It's going to start, running all these algorithms to associate, the images it has seen and the classification we have given to it. And we, again, keep an eye on the loss value that is being reported. The lower that value is, the better the training has happened. So pretty good. Again, you can quickly check. This is me, 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 me. Actually, I'm curious what happens if I come out of the frame. Do you see what happened? It couldn't see my face, so it called it not me. If I do it on the other side, again, not me. If I show my face a little bit, it suddenly starts recognizing. Okay? So you could, again, keep testing. When you're happy with the results you're getting, you then can export the model. And it is this model that we're going to be importing into App Inventor while we are going to start the coding process. Alrighty, thank you. We start the coding process for the PICaboo project. It's probably a good idea to see the final version of this project, the final product. So what I'm going to do here is I'm going to go to Connect, and I'm going to go to AI Companion. And let me see if I can show you what my tablet is seeing. So I'm going to quickly scan the QR code that I'm seeing. So here is this QR code, and when I do that, this is going to take a few seconds, and if at this process your progress bar gets stuck on some number like 49 or 20 or anything like that, it might be a good idea to go back and try what is called the legacy mode, checking that there's a little checkbox that might be helpful. Alrighty, now what I'm going to try is I'm going to play the game of PICaboo with the baby, with the machine. So I toggle the camera so that it can see me. Here I am, and I'm going to press the start button. Okay, now right now the baby is able to see my face, and if you look at the confidence bar at the top, it says it recognizes that this is my face with 99 point plus some value percent level. So it's very high. It recognizes me. Now let's see what's going to happen when I cover my face. The moment I cover my face, observe the me confidence level fluctuates a little bit, but the not me confidence level goes very high. Now let me open my hands, remove my hands. Hope the baby smiles again. Cover. The baby's sad. Open. Now let me cover it another way. You see the baby is again sad. You remove it. The baby is happy again. So you can almost see, I believe, how this could be coded. There's definitely some kind of a conditional statements happening here. If my face is recognized, if it is the me classification, then show the happy baby with the blue greenish background. And if I cover my face, and the not me class is recognized with a high level of confidence, then show the not so happy, the smile, the sad baby face. Okay, so we will be doing the coding here in a few minutes. The coding is actually pretty simple. Observe, by the way, I put down the tablet, and it was pointing towards the ceiling. It couldn't see my face, so it recognized that as not me. Alrighty, we're going to start the coding in a minute. Thank you very much. Hello again. Now we're going to code the PICaboo application. Now, in order to do that, first of all, we have to import the template file from the links that was provided to you. So when you connect with the links, you're going to arrive at a folder like that. And if you double click on PICaboo, you're going to notice that there's an AIA file folder. You double click on that, and it will give you both the completed version and the template version. So I'm going to click on the template, and I'm going to right click and download it. And this should appear in my, let's quickly double check. It appears on my downloads folder. Now, I have personally used the template several times, so I'm just going to give this a number. I'm going to call it template 2, but you could keep it the same yourself, whatever you have. Now, let's see how we can import this into App Inventor. So you go to App Inventor interface, you go to Projects, and one of the options is Import Project AIA from my computer. So I click on that, and it says Choose File. So I need to go to My Downloads, and it may turn out that your template is somewhere else. You just have to know where you downloaded that. So I click on that, Open, OK, and I'm going to get now the template. Now, this might take a few seconds. It's uploading everything. Now, one thing we have to make sure is that when you have the AIA file open, it is not going to have the model that you have trained. So one of the first things we must do is upload the model. So the template is now opening up, and you might see that this is a phone-size version of the app. I'm going to use the tablet size. It's a little bit bigger, and it's a little bit easier to see what's happening. Okay, so I'm going to just quickly double check here. The happy baby, sad baby pictures are there, but what we're missing is the model. So that's the first thing we must do before we forget. So let's do that. So what I'm going to do is I'm going to go to Personal Image Classifier extension that we have here. Click on that. And if you go to where it says model, currently it says none because we have not uploaded the model yet. When you click on that and upload file, again, you need to find out where did you download your model. So I'm going to just download the model upload the model that I had. So model.mdl. If you change the name of this, it's not a big deal. Just make sure that .mdl extension name stays there. So it's going to maybe take a few seconds, but now our model is uploaded. In the absence of this model, you will not have the image classifier recognizes the classes of images that you're going to provide. Great. Now let's go to blocks and see what code is available to us there. Again, we're given some code that is already written for us. And then our main job here is to fill the got classification event handler. Now, before we do that, let's go back to the designer and try to understand what we have here. So you're going to notice that first we have at the top a status label, which is telling us, what is the status of the image classifier? Is it loading or not? And then we have some bar graphs here that are representing the different classes we're going to have. Specifically me and not me classes. So those are the two classes, and you'll see that these bar graphs are going to oscillate back and forth, representing the changing confidence levels. Here we have a web viewer, and this web viewer is going to have our image projected. So the camera is going to take your image and it's going to project it into the web viewer. Underneath that, we have a horizontal arrangement with start and toggle camera buttons. And underneath that, we have a bunch of baby pictures, happy baby, sad baby, So we will learn how to go between these two images depending on the confidence levels. Alrighty, let's start with coding and let's try to understand what some of the existing code is doing here. Now, the first one here, the first event handler, Personal Image Classifier 1.error, it basically, if there is an error, it sets the status label text to that error code. So we have some idea what happened. Hopefully that won't happen too often. The second event handler is when Personal Image Classifier 1, that classifier is ready. So when the classifier gets ready, so we have this event handler called, we do a bunch of things. We enable the start button, we enable the toggle camera button, and then we set a bunch of labels, the status label to ready, bar label 1 to me, representing the me class, bar label 2 text to not me, representing the not me class. So these are the things we do when the classifier is ready. Now the toggle button, when it is clicked, it basically toggles the camera's facing mode. If it was forward facing, it will toggle backwards and it will show you the front, and vice versa. It's just a simple command for toggling the camera. Now the start button, so I'm going to quickly show you what it is. It's basically this button right here. What it will do, it's also actually a toggle button. If when the start button has been clicked, if the image classifier was running, then we're going to ask it to stop the classification and then show the text start. Otherwise, we're going to start the classification and set the button text to stop. So it's basically a tag button that goes between start and stop. Now, the most important event handler here is the when Personal Image Classifier got classification event handler. This event handler is called when a image classification has been done and the Personal Image Classifier is sending you a result. Now, before we go any further with the coding, let us actually understand what this result is, because it is completely not obvious when you look at this little parameter here what result is. So I'm going to actually go back to the slides here, and I'm going to quickly show you something. This is called a dictionary data structure. You may not have used this before. It's a fairly recent addition to App Inventor, and it's a fairly advanced data structure. But the idea behind it is very easy. A dictionary data structure is basically a list of pairs of values. And what these values are, they're called key value pairs. So on the left, you see a bunch of keys. These are English words: apple, boy, cat, dog. And then the associated values with them are the Chinese equivalents of these words. Similarly, you can think of the dictionary, for example, like a phone book. Here you have key as father, mother, Ben, Jenny. These are your relatives and friends. And then the value associated with these keys would be, for example, their phone numbers. Okay. Now, a very important, let me actually go back. A very important block in the dictionary blocks, as we'll see in a minute, is called the get value for key block. And what it does is you give it the dictionary that you're talking about, and you also give it the key that you are inquiring about. And what it does is it gives you the associated value that goes with the key. So, for example, if I click on this, in the context of coding, so when I say, get me the value for key apple, what's going to happen is we're going to find the Chinese version of the word apple. Okay? And then here, if you again ask for value for key, get value for key for boy, what's going to happen is the value associated with boy is the Chinese version of the word boy, and that's the value that's going to be reported. Okay? Now, one final subtlety to understand. Now, in our context, the dictionary that is returned by the GOT classification event handler, i.e. what is the parameter here called result, it's a dictionary, but it is what is called a rank dictionary. So it's going to return us the keys, me and not me. These are the two classes of images that we have, and the associated confidence levels for each of these classes. And note, by the way, 0.925 is actually 92.5%. It is written as a decimal between 0 and 1, but it's representing a percentage. So when we say a ranked dictionary, what happens is the pair with the highest value is reported first, and it is then in descending order. Okay? This was going to become important when we start the coding. So result returned by GOT classification event handler is simply a dictionary, which is a ranked dictionary. Okay, let's get back to our coding here. Now, very important, we start with, you might notice here, with what are called local variables. What makes a variable local is that it is only usable and meaningful in the context of the block where it is defined. Now, global variables can be called anywhere in the program. However, like in this case, the local variable me confidence, for example, can only be called within the GOT classification event handler context. Okay? Now, let me quickly explain what these two local variables are. What these are the confidence levels associated with each of the classes. The first one is the confidence associated with the me class, and the second one is the confidence level associated with not me class. Now, a few minutes ago, we saw a very, very helpful block from the dictionary. So I go to dictionaries, and I see here it says get value for key in dictionary. So what we're going to do is we're going to grab one of these, and if the actually, let's just finish this. So the first thing we have to enter is the key that we're looking for. So for the first local variable, we're looking for the me key, the key that is called me. And then the dictionary we're talking about is the result that the GOT classification event handler returns. Okay? Now, if this value is not found, there's a default text there. So I'm going to quickly throw that in the garbage. And what we need is a number here, which is 0, which is basically saying if there was no classification for the me class, do not report a confidence level, just report 0% as the confidence level. Okay? So I'm going to put that one here. And you're going to notice immediately the get result became meaningful. When I take it out, do you notice there's a cross sign here which says it's not meaningful outside the context where it's defined. So I click on that, I put it into the socket, and then I'm going to just duplicate this because what I want for not me confidence is exactly the same, except I'm going to type here for key, not me. And remember, there is no space between the words not and me. Okay, so this is how we get started, and I hope this is meaningful and it makes some sense. We will continue with the rest of the coding in a second. Alrighty. Now that we have defined our local variables, again, these are the confidence levels associated with each class, me confidence, not me confidence. What we're going to do is we're going to quickly go over the sequence of events with the app. Now, when the classifier gets its classification, and that's, by the way, when this event handler got classification is called, we need to do a bunch of things. One of them is setting the percentage text and the bar graph width correctly. So we have to do this both for the me and the not me classes. So we have to, decide how wide, what percentage of the entire width the me bar graph is going to take, and similarly for the not me bar graph. So we have to set these texts and the widths correctly. And then if the classification with higher confidence is me, and what that means is the baby, the machine is confident that it is seeing your face, then we're going to show the happy baby image and hide the sad baby image. In addition, in that case, we're going to make the screen background color light green, that greenish blue color that you see. Now, if this was not the case, which means that the not me confidence level was higher, we're going to show the sad baby image and hide the happy baby image and make the background color of the screen light pink, as you see here. Okay? So this is the flow of events, and we're gonna start coding this, and hopefully it will make more sense in a second. So let's start by creating the text and the bar graph width and making sure that these are correctly calculated. So the first thing we're going to do is we're going to go to where it says %1, and we're going to grab set %1 text to, and we're going to set this to the confidence value we get from me confidence. So we basically have acquired that value here, but it's a decimal, remember, between 0 and 1. And all we need to do is convert this into a percentage and put the percent symbol. So let's do this slowly. So we need to get the me confidence value. We need to multiply this decimal value, which is between 0 and 1, with the number 100. Okay, and then we are going to use the join block in order to merge this percentage that we have computed with the percentage symbol. So I get another text block, which is the empty block, and I put the percentage symbol here. Okay, so what this is achieving is it is creating the %1 text, which is simply the confidence level for the me class. Alrighty, now we have to set the bar graph width. So we look for bar graph width block. So we take it right here, and this is going to be very similar to what we have here, except it's not going to have a percentage symbol. So what I'm going to do is I'm just going to get this block here, and I'm going to right click on it and duplicate it. Okay, so we want the bar graph width for the me confidence values to be that percentage we just computed. Okay, so that's basically what happens for the me class. Now, the not me class, as you can guess, is going to be almost identical to this. So why don't I just duplicate the first block and then the second block. so that we can just adjust a couple of things differently. Now, first we have to change the %1 here to %2. And then where it says bar graph 1, we're going to have bar graph 2. And then here it says me confidence. I'm going to find the not me confidence level. And then here also I'm going to do the same. Okay? So what we have computed so far is the confidence level for each of these classes, and we are assigning them to the percentages and also adjusting the widths of the bar graphs as needed. Now, just a quick reminder, the next step here is we're going to decide which of these confidence levels is higher. Is it the me confidence or the not me confidence? So you can clearly see there's going to be a conditional that is going to be needed. So I go to control and I go to if then else. So we're going to grab an if then else block, and then we have to make a decision. So let's grab a mathematical comparator. I'm going to grab the equal sign and change that to the greater than equal to symbol. And what we're going to basically say, if the me confidence level is higher than not me confidence level, what that means is we are going to get the happy baby face, because the baby recognizes basically the face. So let's do a bunch of things that we need to do. First of all, let's change the screen background color. So let's set the background color of the screen. And we have given you the blocks that you're going to need. So you could just grab the bluest green block. And that's the background color for the happy baby. And then what we need to do is we need to make the happy baby visible while we are making the sad baby invisible, not visible. Okay? So set happy baby visible to true. So we have to get a logical block here, to true block. And then you could actually duplicate this block. You could right click, duplicate, and then instead of happy baby, I'm going to select the sad baby. Sad baby visible will be false. Now, you might wonder why we are sort of showing one image and hiding another image. Why don't we just, change the images associated with a given, image component? The reason for that is we're trying to basically avoid flickering. So if you have too much switching between different classes because the confidence level is switching, if you do not hide and show two different things, there will be too much flickering, and it's really quite irritating to see that. So that's the reason we're doing it. Now you could guess what we're going to do. You could actually copy and paste these. You could basically use Control C and Control V, just your regular copy paste operations, in addition to using the duplicates. Now the screen background color in the case of the higher not me confidence level is going to be this light pink color. And then what we're going to do is we're going to set the happy baby visible to false while we set the sad baby visible value to true. Okay? So this is basically going to ensure that when the machine is confident that it is the me class that is being seen, then the happy baby is shown. Otherwise, the sad baby image is shown. Okay, so believe it or not, this is all the coding that we need to do. And now we're going to test that all of these are actually functioning as we hope. So let me give a pause until you're caught up. And then in the final part of this presentation, we're going to quickly check that the code is working as intended. Alrighty, in the final part of this presentation, what we're going to do is we're going to check with AI Companion whether the app is working as intended. So what I'm going to do is I'm going to go to Connect, AI Companion, and the QR code shows up. Let me show you my tablet here. What I'm going to do is I'm going to quickly scan, and when I scan that, this is going to take a few seconds. The progress bar, it's going to take about as you see, like half a minute or so. If the progress bar, by the way, freezes, you are advised to obviously try it again. But you can also try what is called the legacy mode. There's a checkbox at AI Companion that you could check, and that might solve the connection issue. Alrighty, so I'm seeing now the camera is facing backwards. Let me toggle the camera and let me start the process of image classification. So here is my face. The baby looks like he's recognizing me. If I cover my face, the baby is not recognizing me and is showing the sad face. Now everything looks okay, except you're going to notice these bar graphs here are they look very limited. It's not very clear why why these numbers are so small. So in order to do that, let's go back to the code and see what's happening. So I'm going to examine where it says bar graph width. When I look at bar graph width, I just realized actually because we're giving it a percentage, we want the percentage of the total to be computed. So these were supposed to be width percents, not widths. That's why. And the moment you do that, the good thing about AI Companion is that everything is live. So you're going to see the bar graphs immediately respond, and now they're in full size. So let's try again. The baby is seeing my face from different angles. I'm curious what's going to happen if I start hiding my face. I'm not showing, the baby's sad. I show up again, the baby's happy. Now let me cover my face. The baby is sad again. Baby's sad. I open my face, close my face. Okay, so you can see that the program is responding appropriately according to what we wanted to do. Now, you might say, what is the big deal here? Like, why did we do a machine learning process? Why did we do image classification? So it's kind of subtle here because there are, thousands of different ways I could be revealing my face to the machine. So I only trained it with, 25 to 50 samples. But from that, the model is able to infer every time it sees my face with some distance, with some expression, etc. And it says, oh, this must be the me class. And similarly, we trained it with only 25 to 50 not me examples. So there could be all kinds of variations, thousands of things I could be doing, all in the not me class. But somehow the model has learned what constitutes the not me class so that it is responding appropriately. So it is kind of subtle. And the reason we are using a PICaboo example with the baby is machine learning is very similar to baby's learning. Baby has to see many, many examples before they can recognize their parent's face. And that's why initially they're kind of surprised. And the parent covers the face, the baby thinks the parent is gone. And when you reveal the face, again, the baby is happy because they can recognize the face of the parent. Alrighty, so I hope this example from personal image classification was of some interest to you, and I hope you'll do many more codings in the realm of AI. Appreciate your time. Take care.